just want to finish up this particular unit on trig equations with some of the more challenging questions, very interesting ones that you'll see. I know I'm not going to put anything like this on your take-home quiz for next week with this unit, but I know a lot of you might be going on to calculus next year, whether in college or as your senior year taking AP Calc. You'll see it again in IB Math 2 and calculus, so I figured let me give you a head start now, and you always have the video you can refer back to. So this is where we left off, more interesting equations, and we have to solve for x once again between 0 and 360, up to but not including 360, and once again we're asked to round nearest degree. Now the temptation here is to cancel tan x from both sides. Don't do that. That's going back to our GCF. If you cancel the GCF from both sides, you lose potential answers. So my first suggestion would be to bring this term over to the left. So we have tangent squared x minus 2 tan x sine x equals 0. There's your GCF. Let's factor that out. You got tan x left minus 2 sine x still. We'll come back to that in just a moment. That's what makes this a very interesting question. But we have a GCF tan x. This gives us a chance to think about our tangent curves. Remember, the odd 90 multiples are undefined. So what angle is tangent equal to 0? 0 degrees as 180 at pi. 360, yes, if we were allowed to include it, which we weren't. So here are our first two answers. But let's go back to what was left over after the GCF was factored out. Set that equal to 0. Now you might be thinking, I don't know what to do next. Well, remember one of the trig identities that we were given? Tangent is equivalent to sine over cosine. Why not substitute that in? And then you'll see, oh my gosh, I have another GCF, sine x. So if you factor out sine x, you're left with 1 over cosine x minus 2. Now I know some of you recognize this from last year in Common Core Algebra 2. Don't replace with a reciprocal function. We don't study reciprocal functions IB Math. Okay, leave it alone. But now we'll tackle this. Fortunately for us, the sine curve where it equals 0 is also at 0, 180, 360. So we would have gotten the same answers from the tangent. So we're good. We don't have to write it down again. But let's combat this. 1 over cosine x minus 2 equals 0. Bring the 2 on over. Remember, when you see fractions, it might help. Treat as a proportion, put a 1 underneath, and cross multiply. We get 2 cosine x equals 1 and dividing both sides by 2. We are trying to find an angle whose cosine is 1/2. So once again, the 30, 60, 90 triangle. But don't forget, cosine is positive in quadrants 1 and 4. So that's why you have two answers there, 60 degrees and 300. There was a problem like this on an old IB exam years ago. But I thought this was really interesting because it gives us a chance to really buckle down with the GCF and that tangent substitution. Now, there's two more examples I would like to go over to help you with preparation for calculus. What if you have sine and cosine double angle together? Well, remember back day 2, day 3 maybe, can't remember, beginning of the chapter, when you both have sine and cosine, what do we do to both sides? You got it. We divided both sides by cosine of x. That way we can create tangent. Turns out we're going to do the same thing here. So divide both sides by cosine double angle, you create tan double angle equals 1. Now I don't know what to do at this point other than a let statement. In calculus, we often call this the U substitution. So those of you who go on taking IB Math 2 or calculus, you'll hear lots of U substitution. So I'm going to let U be 2x. So now I'm going to go back, figure out what angle has a tangent of 1. Well, if you use your calculator, you remember the 45, 45, 90 right triangle. The other one we don't think about, but we should. Let's not neglect it. But tangent is also positive in quadrant 3, so 225. So what I did there, once I know what U is, 45, I can go back to the original let statement and let x be, try to solve for x. So 2x equals 225, as well as 2x equals 45, and you get the two angles, which it did ask me to round to nearest degree, thank goodness, so I get to round up. Last example, this one's a doozy. So I see potentially two let statements. Yeah. Change the 4. In your mind, treat the 4 as if it's 2 times 2x. We had that back in earlier chapter 10, back in early March. So if I let w be just 2x, this becomes cosine of 2w, so cosine double angle equals cosine w. Then you can go ahead and use the cosine double angle formula. Combine your like terms, but I see here we have to factor. And I know a lot of us are still liking a let statement, so here's another let statement. But don't use letters you've already had in the problem. So I had to pick a different variable like n. So if I let n be cosine double, cosine, did I see an x here? Oh my, this should be cosine w. So if I let that be n, I get now a nice factorial trinomial using, once again, our MFRT. So if I use MFRT, it works out really nice. We get two answers for n, positive 1, negative 1/2. But remember, n was a substitution for cosine w. Where's the cosine w equal to 1? At the beginning, at the end of the curve. Now you're probably saying, wait a minute, Miss Dewey, you said not to include the 360. I know, but there's an earlier let statement. Once you know that the angles are 0 and 360, remember this earlier let statement here, w equals 2x? That means I gotta take the 0 and the 360 and set them each to 2x to find the original angles, which were 0 and 180 degrees. Tricky, I know, right? And then the cosine w equals negative 1/2. I know cosine's negative in quadrant 2 and 4, so the reference angle being 60, I get 122/40. But remember, the original let statement, once I have the angle, I gotta solve for the original x. So these are the w's, technically speaking. So what I did next is set each of them equal to x to solve. Yeah, I put x's here. Let me make this easier for you. They should be w's here. Those are the w's. These are all the w's that I found. Those are all the w's. So I had to go backwards to the first let statement I wrote to find the four answers. So like I said, these kinds of substitutions come in kind of handy when you start studying calculus. But I wanted to make sure, at least I talked about it once with you, give you a chance to try some of these problems to finish up the trig equations chapter. Those are all the lessons, all the notes. I'll be giving you lots of practice problems, and next week, the week of May 18th, I'll give you another take-home quiz to work on. Thanks. If you have any questions, let me know.